So hi, this is me Aryan and this is my final project Alternate 01 linear regression. So let's go through this first of all. So the objective is like to create and test the abilities prediction using supervised learning. So here we are to deal with data sets, and this is a description of data which is given over here. So you can see this is the data which we can see here. It's like given in x1 and this is displayed. What is x1? X1 is total overall reported crime, so it's total, and then this reported violent crime per 100,000, and then x is 3 annual police funding, x4 25% plus 25 years plus, and there's x course of high school, the people who are in the high school 25 plus, and then the 16 to 19 years old who are not in high school and not in. So this is the description given of this data. So what have we to do? We have to do this, perform this 7 tasks. So first task is like to successfully import and display the shape, and let's go through it. So this is what task we have to do. So here, so first of all we are importing the data frame. So we're using the pandas library to do that, and here my df is equal to reading. We are reading the csv file here. So it's gonna read that file, and now we need to display the shape. So we are using this display mydf.shape. What is the shape? There's 50 rows and 7 columns. As you can see, there are 7 1 2 3 7. There's 50 rows and 50 rows, and this is count. This is like, and this is the summary. Like if you want to check the summary, it's like mydf.describe, and this is your, how can you can see like what are the, how the data is divided, like how the data is. So like as you can see in the summary here, this how it's like 25 plus 7 5 5 16 and then all that. So described here, and then you can see this info of the data also, like it's all of them are integers data type, and then total memory we are using is 2.9 KB. So what we have to do in like do right now, plus we have to check if there's any non-applicable values, like any missing values. So there are none right now, so there's no missing values in the data set, the data frame we have here. And second, like thirdly, we have to do this plotting the data. So we have to create a like plot chart here. So you can see create a plot. So plot the data using matplotlib. So like at least 2 different. So first we are doing with histogram. So like we use this library, and then we are going to use the bins is like how many bins you want, like here, like what is, and then the size, figure size is 7 by 7. So this is like length and height is 7 by 7. So here this is the histogram and showing the all data, and we're showing the that in line. So like I don't need to do this again. Let's see if still work. It's still working. So yeah, so this is like line graph. So it's showing line chart. So this is how data is. This is to like this whether those data are very tiny, so like you can't properly see them, but those data are. So like if I do increase the size, maybe we can see it more like clearly. Like this you can start seeing some of it. So yeah, those are like very tiny and like very low values, and this is going to very high value. So like it's capturing the high value, and then it's not able to show them properly, but yeah, this is the number. And now we need to split the data and then train and do all that stuff. So first of all, we're using like feature calls. So like we're putting those columns values in the feature calls, so that it's easy for us like to show, like use them in future also, plus easy for eyes also, like it looks more readable. So for what we did, we used like we put all the columns, like no except one, we put all x2 x3 x4 here, and then and then we're gonna do it, and we put all them in x value. So here we are reading my location, and then we are reading all the rows and feature columns, and but the feature columns doesn't consist all of them. and it doesn't consist all of the columns, so it doesn't have, x1, and then these are the values of those columns. And now we're using y for like x1. So what we need to do is like, this is the features and this is label for how we're going to test and train the data. So we put x1 in y, so those are the values in y. Now we need to split the data, and for that we are using this library. From this library import this train test split method, and then we're going to use it. So we are training x train, and we're using for training all those data and then testing all those data, for those column data, and then for y trains training those older, and we're going to train it future, but like right now test and then put test, so that we can do it in future. So train test split, and then this is what we are using. So for x, and then it will count, and then for y this is. So test size is 0.3, which is 30% of it whole data. So this is how it's gonna test, how much data is gonna use to test the data, to learn. So now we are using this library sklearn.linear model. So this is a linear regression, as we have learned. So we have to do this. It's linear regression. So now we're importing logistic regression. So logreg is equal to, now we are using this value, putting this in this logreg, and then logistic regression solver. We are using a solver, but if we don't, there are different solver, it will show error, but if you use this it will not. And if it shows error for you, just do this. This is the old way of doing it, and this new way you can just go write it like this, LGBFS. Yes, this is the newer way of doing it, but yeah. So we are using this all linear and then logreg, and now we are training the data. So we are training the x train, all those columns x1, x2, x3, and training those, and then training y. So it's gonna train and see, start learning. So this is the learning progress of the machine. This machine is now, this method, this function is learning now how is the data and how it's working. So now we are predicting. Now we have to predict. So now the machine is gonna predict how the values are gonna be, closest prediction. It is gonna learn. So we are using this my prediction. We are creating a data frame so that we can read how the values are, what are the values, and how it's working. So we put it my prediction is equal to pd.data frame. Pd is perform pandas, and then real value. What are the real value? Y test. So y test the real value, which you can see here. This one, this whole first one. So this is the real value we got, which we are given. Y test. So this is total annual death rate, something criminal rate, and then this is the prediction value, what system is putting out, system is generating. So in the prediction value, now we're gonna read it, let's say read more than 5, so much, so we can show it. So this is the this 912 actual, but conversion is 821, and then look, it can be, so it's over here. So we will find somewhere similar, almost similar, but yeah, this is this is not that too far from first. So what is the real value and what the system predicted? So now in the last task, we have to just calculate the mean squared error. So for that, you can just go from sklearn import matrix. So this is from go this library and then import this matrix, and then I'm using mean square. This is MSC mean square. I put all that value in this, so that put it here, easily very readable print method. What is going inside print? So what we are doing, we are just using this matrix dot mean square error. This is the method, and then we are doing this. We're testing y test, which is the values, total values, and then prediction values. So checking what are the error, what is the mean. So this is the mean it generated. So this is 99205.8, and my prediction. So plot, you can see how far the prediction value is from the real value according to it. So like it's not like you can see like you start getting it, it's not that far, but like there is still like differentiate. We can just decrease the size to 0.2 maybe and then check it and then redo it. Oh yeah, this you can see it's like much closer now, not that far. All of these values comes closer now. Decrease the training test, now it's getting 20% of test, and then look the real value and then actual value, prediction value. You can change it, like you can just see how much you want to put like test size. You can increase it also, like, and then see what are the results are now. So you can see now the real values, like it's like very lower, but like start mimicking it like very well now because we provided more data to test it. So yeah, that's it, I guess. That's it. Thank you for watching.